Welcome to section 1.2 in differential equations. In section 1.2, we're going to be solving differential equations by simple integration. So, in question 1 here we have a first order differential equation. They are giving me an initial condition, y at 0 is 4. So I want to find a function whose derivative is 4x cubed plus 2. Now you know this is simple integration because there's no y's on the right hand side. So power rule for integration, x to the n, increase the exponent by 1, divide by the new exponent. So antiderivative of 4x cubed is x to the 4th. The integral of a constant is 2x. Because this is this kind of integration, we pick up an arbitrary constant, and that's why we need the initial condition to determine what that is. So, plugging in 0, 0, 0, I get that c must be 4. So the solution to our differential equation and the initial condition is shown there in the box. All right, in question 2, we continue this. I got the derivative is 4 over x squared. My initial condition is y at 1 is equal to 3. So to integrate this, I need to convert it into a form that I can use my power rule. So this is 4x to the minus 2. So add 1, divide by the new exponent. And so I get 4x to the minus 1 over minus 1 plus c. And so if we clean that up a little, we get minus 4 over x plus c. But y at 1 is supposed to have to equal to 3. All right, so plug in 1. And so I get 3 equals minus 4 plus c. Move the minus 4, and so I figure out that the constant is 7. In question 3, similarly, we've got the derivative is 1 over the square root of x plus 4. Initial condition is y at 0 is minus 3. All right, so looking at the integration I have to do, it's not in a format that's very useful. And so I need to rewrite it with an exponent. But as soon as I do that, I know I'm going to have to do this integration by substitution. So I let u be the stuff on the inside. The derivative of that, du, is dx. And so that turns this into an easy thing to integrate. Minus a half plus 1, minus a half plus 1 plus c. The fraction on the bottom flips up, and so I get 2 u to the 1 half plus c. What was u though? U is x plus 4. So my solution is given here. I now need to use my initial condition, and the initial condition was y at 0 is minus 3. All right, so plug in x equals 0, square root of 0 plus 4, that's 4, square root of 4 is 2. 2 times 2 is 4, and so move the 4 over, and I get that c is minus 7. So, using what we found before, plugging in c is minus 7, we get our final answer. In question 4, similarly, we want to solve this by integration. Y at 0 is 0 as my initial condition. So let's see. Y is going to be this integral, and hopefully that looks familiar because the integration of 1 over x squared plus a squared is 1 over a inverse tangent x over a plus c. So the 9 is 3 squared. I took the 3 out in the front, and so we're going to get by this formula 3 times 1/3 inverse tangent x over 3 plus c. The 3's cancel, and so I get the inverse tangent x over 3 plus c. All right, y at 0 is 0, so plug in x equals 0. Yeah. So the question is, what is the inverse tangent of 0? So if you have forgotten some of those things, refresh your memory. But the inverse tangent of 0 is 0, so c is 0. All right, in question 5, we are looking at the position for a particle moving with acceleration t. It has an initial position of x0, which is 20. It has an initial velocity, v0 is 40. And they're telling me that the initial acceleration is minus 60. All right, well, if we integrate acceleration, we back up to get velocity. And so if I'm integrating minus 60, I get minus 60t plus c. So now I want to get into the game my initial velocity of 40 at time 0. So c is 40. So I've got this formulation now for the velocity as a function of time. And if I integrate velocity, I get the position function or displacement. So I'm going to integrate minus 60t, so a minus 60t squared over 2. Integrate 40, I get a 40t, and the arbitrary constant we pick up. All right, so we're almost there. We now need my initial position of 20. So plug in t equals 0, t equals 0, and so I get that c is 20. And so this gives me a formulation for the position of this particle at any time t. All right, similarly in question 6, we are given initial velocity is 5, initial position is 0, and the initial or the acceleration as a function of time is 5t. All right, so integrate acceleration to get velocity. All right, so I get 5/2 t squared plus c. At time 0, the velocity is 5. All right, so plug in 0, and so I get c is 5. All right, so now that I've got velocity, I integrate that to get position. All right, so integrate t squared, I get a 1/3 t cubed, so a 5/6 t cubed. Integrate the constant 5, I get 5t plus c. But at time 0, position is 0. So that would give me 0, 0, which says c must be 0. So my position as a function of time is given there in the box. All right, what about this one? Let's see. We are given acceleration. The initial velocity is 0. The initial position is 0. All right, so I need to integrate this thing. All right, so I'm going to pull the 2 out. I rewrote this as t plus 2 to the minus 3. It's a chain rule. I need to use integration by substitution. So let u be the inside stuff. du is dt. So power rule to get my formulation. And so let's see, 2 over minus 2 is just a 1. And now I fill back in what was u, and that's t plus 2. All right, so kind of ugly. All right. At time of 0, v is 0. So what does that mean? So that's a 0. I get a minus 1 over 2 squared. And so a minus 1/4. And so c is 1/4. All right, so that gives me my formulation for the velocity at any time. I still need position, so I need to integrate this one more time. All right, so let's divide and conquer. I need to integrate this first piece and the second piece. Well, to integrate 1/4, that's easy. I just get 1/4 t. To integrate this term, well, let's see. Well, again, that's going to basically be what we had previously. And so I'm rewriting this as t plus 2 to the minus 2. And so when I integrate that, we get finally that x of t is this. At time 0, x of 0 is 0. So plug in all the places where t is 0. And we get that c is minus 1/2. All right, in question 6, we have kind of an application problem here. Hopefully it's visible. We look at a particle that starts at the origin. Okay, so that's important. That means my initial position of x of 0 is 0. And we have my velocity function given by this graph. So we want to figure out what would the position function be from 0 to 10. So they did not give me a formula for v, so I'm going to have to figure out what that formula is. Well, look at this part. V is flat. It stays at a height of 3 from 0 up until 6. So 0 to 6, it is the constant function 3. On this portion from 6 to 10, we have a line going down, so it's got a negative slope. It's connecting the points 6, 3, and 10, 0. So what is the slope? Well, I can read this from the formula. I move over 1, 2, 3, 4. So the run. Go down by 3, 1, 2, 3. So the slope is minus 3/4. And if I use the point 10, 0 along with point slope formula for the line, I find out what is the equation of that line going from 6 to 10. Now you might say, how did you know to put the equal on the 6 or the equal on this 6? And it really doesn't matter, but it can't go on both. Otherwise it wouldn't be a function. So whether you put the equals here or the equals here, it doesn't matter. So, to figure out my position function, I'm first going to figure out what's going on from 0 to 6. All right, well, that's easy. I'm going to integrate 3. Well, the integral of 3 is 3t plus c. But how did I suddenly get rid of the c? Well, remember, we started off at the origin, so c is 0. All right, so that gives me my formula for the position on the time interval 0 to 6. So at this point, we know where the particle is at the start of the next time period. Because when t equals 6, I got 6 times 3, or 18. So that's going to be my initial position at 6. All right, so on that time period, I go back and I grab my formula for the velocity on that segment and we integrate that. So I've got a formula for my next time period. That's where the c comes in of where we left off. So plug in t equals 6 into those places. So plug them in there. And what we find out is that c is a minus 13.5. So let's see, what does my graph look like? Well, it was 3t, remember? So it comes here. At time 6, it's 18. On the next period, it is a quadratic function. So it looks like a parabola. It's got a negative lead coefficient, so it's a flipped over one. And so it looks like that. And so if I'm trying to figure out which graph is it is going to be C. And here's the actual formula for my position function. All right, in question 9, if an arrow is shot straight upward from the ground, meaning my initial position is 0, we get an initial velocity because it's being shot upward, so it's a positive number. If all of this is the case, how high is the arrow going to go? Well, we have a formula for positions of projectiles. So minus 1/2 gt squared, my initial velocity, and my initial position. So let's plug in, what do I know? G in terms of meters per second squared is 9.8. If we had British units, it would be 32 feet per second squared. But here we have meters per second squared. And that's the units with my initial velocity as well. All right, so let's see. Position was 0, initial velocity. So I get that y of t is a quadratic function. The quadratic function is flipped over, so it's a flipped over u. Since it's a flipped over u, it will have a maximum position, maximum height. How do I find it? I find it when y prime is 0. I'm looking for the critical point. So differentiate that, and here's y prime, and you can solve for the time that it occurs. I need the time because I need to use my position function to figure out where we're at. All right, so it happens at 4.7 seconds. Plug that in. And so we have 108.241 meters. All right, question 10. A ball is thrown straight downward from the top of a building. Okay, well, if I'm going from the top of the building, okay, I need to make some assumption. Where is 0 here? And so we're going to use the top of the building as 0. It's thrown downward at 12 meters per second. But we're going down, not up, so the initial velocity is a minus 12. All right, so given all of this, and it strikes the ground at a particular speed, how tall is the building? All right, well, let's see. Got my position. Okay, so y at 0 is going to be 0. My velocity looks like this. All right, so let's see. Got g for gravity. My initial velocity is minus 12. And so what was my final velocity? Well, they said it was hitting the ground at 55, but wait. Remember, we've recorded down as negative. So that's a minus 55. And so if I solve for the time when it actually hits the ground, it's at 4.38 seconds. So how tall is the building? All right, well, let's see. So you plug in this into my position function, and we find out that the initial height is going to be 146.99 meters. All right, and in question 11, a stone is dropped from rest, so my initial speed is 0, with a height above the surface of the earth. And they're telling me that the speed that it hits the ground is that formula for velocity. So let's see, what do I know? I know that initial velocity is 0. Initial height is h. I know the acceleration is downward, and so that's a minus g. So integrate that to figure out what is the velocity. All right, I can see I have a typo here. This should be a of t. All right, so we integrate that and we will get the velocity. All right, and so the velocity is minus gt. And so I can integrate that to get my position. All right, but at time 0, we get h. And so we figure out that the c is h. All right, so x of t is minus 1/2 gt squared plus h. And that's when the stone hits the ground is position of 0. And so the time for it to hit the ground is the square root of 2h over t, taking the square root here. I don't have to worry about the minus because time is positive. And so the speed where it hits the ground is, I can fill in the square root to h over g because that's the time. All right, so let's see, I need to clean this up. So I'm going to rationalize this by multiplying top and bottom by the square root of g. And so that cancels. And so speed is the absolute value of velocity. So the speed is doesn't depend upon plus or minus. And we do actually get the square root of 2gh.